Welcome back, everybody. So just to pick up where we left last time, we used this IQ recording that we made. So we took it from this software. We went to the FM broadcast band, and instead of listening to the FM station live through this demodulator, we just recorded the IQ sample. So we played how it looks like. So now what I did is I added a FM demodulator here, and it's going to go to the audio card of my laptop. So just hit play. Okay, so that was the local Quran station where I live, and you can see it was about 5 seconds long, like we made for the recording. So everything looks good here. So this FM station, it's going from 99.9 to 100.1, about 200 kilohertz, so everything looks right. What we can notice though is that we had to put in a sampling rate, and if we go to the IQ recordings, here it tells you the center frequency and it tells you a timestamp. It doesn't tell you the sampling rate. And even here, this IQ recording that we made from this wave file, we don't have any information about the sampling rate. And for this software, there's lots of different sampling rates that you could have chosen, and you don't always remember what sampling rate you used. So where that will affect the signal, I'll just go by example. I'll say that, let's say that we're using double the sampling rate. So what's going to happen is that we'll still see the signal, but yeah, you can hear the audio was messed up. So for analog signals, you're going to severely degrade the demodulated signal. For digital signals, you won't even get the correct data at all. And another thing we can notice is that it went to about 2.5 seconds instead of 5 seconds. So that's because we were at twice the sampling rate than reality. The signal is going to look the same, but this scaling on the x-axis for the time is not going to be correct. And also here, same shape, but now it's going from 99.8 to 100.2, so 400 kilohertz. So you know that can't be right for an FM station. So that's why it's important to know the sampling rate of your IQ recordings. But the thing is, you're going to have a bunch of IQ recordings, and the sampling rate is just nowhere to be found, and you're going to forget what sampling rate you used. So other than the sampling rate, you might be thinking, where were you? What were the GPS coordinates of the recording? What gain settings were used? The antenna, were you using a omnidirectional? Maybe you were using a satellite dish antenna. If it was a satellite dish, where was it pointed? So all of these things, you can't just keep adding things to the file name. So somebody thought of a smart way to solve this problem. It's called SigMF. So SigMF is just a protocol. So we can open this link and you can read all about it. But basically, it's a nice way to manage your IQ files. So if you just say start browsing, I already downloaded this first signal here, an analog FM station in France. So what you do is you can download the data and the meta files, and I already downloaded them here. So here, this data file, it's going to be quite large. However, for the IQ samples, 705 megabytes. But then this meta file, it's going to be much smaller, 561 bytes. So it's actually a text file, a JSON. And here is how we solved the problem. So he put the gain that he was using, the antenna that he had, the data type of the IQ samples, the sampling rate. This is very important. He made a description. So he tells you that he was recording the FM stations. We have our center frequency. So the way it works is that every IQ recording, this one, will have a second file with the exact same name, but the ending is different. So this is called SigMF-data, and this is SigMF-meta. So we can turn our IQ recording into a SigMF simply by, first step is taking the name, and instead of .iq, I'm going to say .sigmf-data. So now our IQ samples are in the right format. And what we can do is now you have to make a meta file. So you can just use this one as a template, and I'm going to say you can type anything, but I'm going to say FM station where I live, and 96.9, it's going to be 100 instead. So I'm not going to actually save that, but that's all you would have to do. And these SigMF datas, we can do like last time. We can put them into Python. So if you're going to load into Python, just a quick note, it says complex float 32, but if we're going to load it into Python, I recommend loading it as complex 64. So you can do float 32 like it says, but if you use complex 64, it's going to automatically take the first float 32 and then just take the second one and add a j to it to make it a complex number. So the way that works is I'm gonna print the length of both of these, and then I'm gonna print out the first 4 entries. So the first one, that we loaded as float 32, it has 176 million samples. So that sounds not right, because here he's saying that he has 88 million samples. But then if we look at the first 4 entries, we'll see we have just 4 numbers. Whereas the second one, when you load it as complex 64, we have 88 million samples, which is the correct number, and it's going to take this first number and join the second number to it with a j. So this is the IQ format already directly. So you don't have to do the interleaving step like on the first and second videos. So we can do all the same things like last time, such as printing out the number of samples and finding how long the recording was. So this recording was 45 seconds. So for example, we can just go ahead and play it. Where is it? Pick the data file, not the meta file. And then if we hit play, we should be able to, sorry, I forgot to change the sampling rate. So if we hit play, we'll hear this FM station in France. Yeah, it's in English, but they said it was from France. So anyhow, you can see it works nicely. And just to work on a second example, so I went to this drone folder, and this guy uploaded a bunch of DJI Spectrum recordings. So I took one of them, I think the Mavic Pro, 120 million samples, and the sampling rate. So I already downloaded it, and the only difference here, since the data type is different, sorry, battery died. Anyways, I have the Mavic Spectrum recording, so I'm just going to hit play here. So the nice thing with IQ recordings is that if you need to take a closer look at signals, like you can see here, there's some hopping control signal. It's so fast. Then you have your video link here, of course, with a wide bandwidth. What you can do is, I'm just going to put a max hold, and it's a better way to analyze the signal. But in order to do this, you have to have the IQ recordings, and in order for the IQ recordings to be useful, you need to have metadata associated with each one. So anyways, I hope that was a good introduction on using IQ files. I have some more code here, but it's really just more of what we went over in the first and second video, such as plotting the IQ samples. But anyways, just to wrap this up, so IQ data, it's usually recorded as 8 bits, 16 bits, or 32-bit integers. So we can turn them into IQ samples by making them into the I plus JQ, and you can scale them between -1 and +1 if it's not already natively in that format. So if you use the complex 64 or float 32 types IQ recordings, you don't have to do anything. It's just ready to go. So I recommend using Python if you want to work with snapshots and look at a certain amount of samples at a time. But if you want to see live playback or try different demodulations, I would recommend GNU Radio or some other softwares. So You should consider using SigMF protocol so that you can manage your IQ recordings in a good way. And finally, I'll just add that if you don't have a nice antenna or if you don't have a good setup, such as like a line of sight or on top of your house, if you're in an apartment complex, you can't get too many good signals. So you can just benefit from websites like IQ Engine or SigID Wiki is another good website to check out for IQ recordings. Anyways, thanks so much for tuning in, and I hope you have fun with the rest of your IQ and SDR journey.